Having calibrated all three tools, having set the top surface as our Z0 work origin, having set a maximum depth, and having set our X and Y work origin as well, we have done everything we need to actually execute a toolpath on this side of the glass doors at least. We still need to slightly open the air suction valve by the cleaning station in the main workshop, so as to make sure that the dust extraction here works properly, and we also of course have to send the actual file to the machine. But on this side of the glass doors we are fully prepared. Bring the CNC controller with you, carefully watching the cable, and go to the other side of the glass doors. Put the CNC controller in a safe place where it is not at immediate risk of falling over, because falling over and accidentally pressing the emergency shutdown key would mean that you would have to redo almost every step of this. And then we can take out the CNC cable here, just as to make sure that there's one less cable at the risk of being damaged there. Very good. And now, depending on the material that you're cutting, it might be mandatory to have this glass door completely shut. If it's MDF, which during milling leaves very small particles that is toxic to your health, you will need to have this door completely shut. But if it's plywood, as in this case, we can simply slide the door. Let's see if we can slide the door so that there's only a small gap there. That minimizes the risk of us getting hit by any debris, but it still makes it a little less complicated to enter during the pausing of the milling. All right. The way the dust extraction system in the CNC room or with the CNC machine is wired, the only way to make sure that it is 100% on or on during all of the time during milling is to actually open a small air suction vault here. Otherwise, the dust extraction in the CNC room will be on only when the dust extraction system is activated as another machine in the other parts of the workshop is activated. But here there's this option. If you perhaps position that there, and you see here that there's a switch here, the only amount you need is to actually open it like that until you hear the click. But only hearing the click is not as soothing to my mind as I require it, so I open it like this just to make sure that I hear air suction, and then I close it again until the air suction noise is minimal. This is of no discomfort or concern to anyone else working in the workshop. And then I usually position this like this just to pinpoint that it is not completely shut, but it's still intentionally left open. Having this slight air noise also helps you to make sure that you actively close this after the successful milling. And this is also available to read about here. All right, I can shut it down, shut it a little more. There. Now there is no sound at all, actually, perhaps a little. Like that. The main point is that this should be activated. If this switch is active, that means that the dust extraction system is properly activated. Make sure to bring out the chair as well so it does not get covered in sawdust. Things might be a little cramped outside the CNC room doors, but try to fit everything as you can. Now, when you are 100% sure that you have done everything according to procedure in the CNC room with the CNC machine, that the computer is on, that the that the air suction vault is slightly open so as to allow the dust extraction system to be on 100% of the time, and not only when other machines are actively used in the other parts of the workshop, you can actually execute the toolpath. And to do so, you go to the CNC controller And here, just to minimize the risk of this falling or dislocating from your hands or any way, I would recommend that it's actually positioned on the table as this. You can of course have it in your hand as well, but here, as for my demonstration, I cannot hold it as my other hand is holding the video capturing device here. So to actually execute it, if the computer is on, if you have placed the toolpath files in a subdirectory of the DNC files directory on the local drive C, then you will see actually this button here. As long as it's you see that it's white and it does not have a red cross and circle above it, that means that there is an active connection to the computer. And if you then click on this button here, the machine bed Ethernet cable computer button here, if you click this, you will see connecting to host. It connects to host, and then the previous subdirectory that we were in is shown here. So we can simply press the Z key here so as to go to the uppermost option of the list view here. The 3 dots, I would say, but it's actually 2 dots in this interface. The 2 dots mean that we go up one directory, and here we are in root. This is the folder that is actively synchronized to the CNC. And here we go, I think it's up to Eric. Yes, here we have Eric, and we press enter to go inside here. And here we have our 1, 2, 3, 4 toolpaths. And here we see that it's so important to have a short and concise file name with the most distinct part of the file name in the, perhaps not in the absolute beginning, but not farther, not beyond the middle of it, because the file name can easily extend beyond the maximum allowed characters showing here. And then we simply now, if we would have known, or if there would be plausibility that these 3 toolpaths would be able to be run in one session, during one day, during the opening hours of the workshop of one day, then we couldn't run this merge toolpath. But as we know the circumstances of this particular toolpath or set of toolpaths, we know that this will take 2 days, no matter how we distribute the time of the toolpaths. And thus there is no need for us to run the merge toolpath, only to cancel it halfway, but we can instead run these 1, 2, 3 toolpaths separately. And if you click enter, if you click execute here, or the action button, you will be asked for confirmation as to execute the toolpath or not. But if you click the enter button here, you will see a preview of the toolpath. So here we see a preview of the toolpath, and this is very good because you see that as long as the long axis of the CNC controller is co-aligned to the long axis of the CNC machine bed, then you know that the display also shows an oriented view. So thus we know that this is the x-axis, this is the y-axis, this toolpath, the graphical representation of it, it's very representative of what we have previously gotten acquainted to in Fusion 360, so it's very good. And we could run this by clicking execute, but we want to check the others as well, so we click cancel here, and then we go to tool 2, and you saw that tool 1, toolpaths which are executed with tool 1 residing in tool holder 1 are blue. The toolpath is blue. If you go to tool 2 here, you will see that it is red. And this is our roughing toolpath, and it is also, according to how we expect, having gotten acquainted to the toolpath previously during the simulation in Fusion 360. We can click cancel to go back. And let's check out the third, tool 3. And tool 3 is another shade of blue, or perhaps a little more to the purple hue. And here we see that this is also according to expectation, because this is only a 1mm step over, and the resolution of the display is not enough to show anything else than a huge blob. Alright, click cancel, and we can of course see all the 3 of these merge if we preview this merge toolpath. And then we see these 3 different colors, like this. And and the third toolpath with tool 3, it really makes it hard to see anything else. But we have previously pressed cancel to cancel that. But we have previously verified that everything looks as they should with the separate toolpaths here. Now, as we are ready to execute this toolpath, having made sure that procedure has been followed and that we are ready for this, we can click enter just to double check. Preview once again that this is the intended toolpath. We see here that it's the first toolpath. It's got a blue U, it's tool number 1. Then we can click execute to execute it. It stands by, or please stand by, and now if you press execute again or start, that means that you will execute the toolpath. You also have the opportunity to cancel with the cancel button. And one thing of note before starting is that you can, whenever in the toolpath, you can press this yellow button, this pause button, and that will pause the rotation of the spindle, retract the spindle, and you will have an opportunity to go to the other side, to go inside the CNC room and watch the results, where it is now. Alright, but having made sure that all preparations are complete, we can press action. You may, at any stage in the toolpath, pause the operation by clicking the pause button here. For reasons undeclared, we will pause it there. And while pausing it, it retracts the spindle and it halts to a stop. And now it is paused. When you press enter and confirm continue here, you continue or you resume the toolpath at the exact moment that you paused the operation. For now, we can put the CNC controller in a secure place where it does not risk of falling down, and we can enter the CNC room. When you have paused the toolpath, you are welcome to enter the CNC room and visually and tactically evaluate the result of the toolpath, although it is only a part of the toolpath, of course. Here, due to the settings used and the tool used, a ball end mill, we can clearly see the scalloping here. We can see that there are some frizzing on the edges, but I would say that they are marginal. Here we can see that some of the model or some of the resulting surface texture is deteriorating due to very small elements, but this should be sacrificial of material should be diminishing when we continue with the roughing toolpath. This is only for the clearance toolpath since we have an offset of 3 millimeters, and you can check for signs of rubbing. Here one might say that we have some signs of rubbing in the corner here, if this is not, perhaps that's part of the actual layering, so that's a very bad example of me. But here we see more clearly. I would say that this is a sign of rubbing, and the reason why it turned this darker hue is because the router bit or the tool here, it rubbed the surface and caused it to darken and close to burning. But that was only when we pause. Because when it pauses, it immediately stops in the X and Y direction. And then it continues to rotate a little, and that could lead to burning there, or to rubbing in this case. But in any other areas, I cannot see any signs of rubbing, so I would guess that the feed rate and spindle speeds are adequately set. We may continue the toolpath after having exited the CNC room. Having exited the CNC room and being on the safe side of the glass doors, we can resume the toolpath, have continue, the continue option here selected, and press enter to confirm. This will continue the operation at the same position it was previously paused. One thing to note here is that when the tool is ramping, as it does now, you might be appalled at how the feed rate is increasingly increased along the radius of the ramping, and that is because the feed rate is automatically adjusted based on the percentage of the radius of the tool that is engaged with the material during cutting. And when the radius of the ramping circle or spiral gets larger and larger, that makes the percentage of the tool's engagement in the material smaller and smaller. So that is why it increases the feed rate significantly. But that is nothing to be appalled of. Always supervise the CNC during an active operation. If you need to go to the bathroom or anything else, you can press the pause and pause the toolpath and then resume when you have returned, but never leave your supervising position during an active milling. You do not always have to have the CNC controller in your hand. You may carefully rest it on the table here, as an example, but make sure that you're always within reach. For a critical situation, to push the emergency button, and for a non-critical but still confounding situation, the pause key. If something seems to go awry but nothing of the critical sort, then you are free to anytime click the pause button and the toolpath will pause, and you can go in with the rotation of the spindle off and the spindle retracted. You can enter the CNC room and check if everything goes according to expectations. But if something of the more critical sorts seem to be happening, you hear really loud noises or something that needs to be aborted immediately, then you of course press the emergency stop button. When the toolpath completes, you will see that in the CNC controller interface, you see the main interface again and not the executing toolpath interface. And the spindle has stopped its rotation and is positioned slightly over 15 millimeters above the work origin. If this would have been merged multi-toolpath file that we're executing, then you would have been greeted here in the CNC controller interface. It would have automatically paused if the change in tool paths would have incurred a change of tools, and it would have paused, and you would be asked to confirm with the enter key to continue. It will be similar to the pause menu, and then when you press continue, the spindle will for some reason start to rotate just an instance, and then it will stop again, it will retract, and it will go to leave the first tool and fetch the second tool for the second toolpath in the toolpath file. But since we are now running separate toolpaths, we may now simply go inside to clean, just a rough clean of course. This is not the end of day cleaning, but simply between toolpaths cleaning. And one sound thing to do before that is to jog the machine, or jog the spindle away, so we can jog up instead, up to there, and we can move the whole y-axis away along the x-axis, just so that we have adequate, that we can reach the machine bed to clean it. Like that, and after we have entered the CNC room and cleaned up a little, then we can resume outside here and continue with the second toolpath. To clean in the simplest way possible, you may fetch one of those large rubber hoses, large black rubber hoses, usually hanging there, but now positioned here. And now, let's see, connect one end here. And then enter the room and clean this one. Be careful when cleaning around the areas of the vacuum inlet, so that these vacuum inlet blockers are not getting sucked up as well. Make sure to return the black rubber hose to the intended storage placement. Now at this stage, since we are milling several toolpaths in one day and have at least one succeeding, the in-between cleaning does not need to be perfect. You might leave it looking like this. It's no problem. The main thing is that you leave the floor as clear as possible, so that you don't slip on any sawdust, and that you don't allow the machine bed to be fully covered by sawdust as well. But just roughly clean it up with the rubber hose, and you'll be back to running the second operation in no time. Alright, having run the first toolpath operation here, the clearance toolpath, one may examine the results. In this case, I think that it looks precisely as we would have expected. Since we have simulated in Fusion 360 and exported the simulated preview stock into Rhino, we are already pretty well acquainted to the result here. But of course, since it's an actual material and not a perfect idealized simulation, we see here some frizzying, we see that there has been some deterioration of the material, and this is something to be expected since we're milling in an actual material and not just in an idealized simulation. Very good. So in this particular case, this toolpath operation took actually only 1/10 of its simulated time in Fusion 360. Its simulated time was 10 hours approximately, and here it only took 61 minutes from start to finish. If we would have been satisfied for the day and resuming, or not resuming, but initiating the next toolpath during the next day, then of course the machine would have to be shut down. And shutting down the machine would mean that you would lose the calibrations that you have made. You should do that again the next day. And since you in that case would have lost both the X and Y origin as well as the Z origin, the top of surface, if you, like in this case, this you already know from the simulation, but the clearance toolpath leaves the actual top surface of the stock. It leaves this due to our settings. It does not mill the top surface for 1, 2, 3, 4, 5. Perhaps this as well, but this has been deteriorated. But at least for these 5 areas, the top surface is still existing. But if the toolpath would have engaged in all of the top surface, would have milled away all of the top surface, then it is important to know that when you want to resume milling, or when you want to do the next toolpath a separate day with the power breakage in between, thus losing the Z origin as well as the X and Y origin. The X and Y origin is very straightforward to recover as long as the material itself remains in the same location. Then the soft home X and Y coordinates that you have taken note of before when you set the home, or at the instance before setting the home. Since you have taken note of these X and Y coordinates, either at the same instance or immediately before setting the soft home, then you already have these X and Y coordinates, and when the next day calibrating or setting the soft home, you simply, after having the machine hard homed, having found its machine coordinate space origin, the X and Y and Z 0 for the X and Y and Z axis on the actual machine, then you can simply navigate by jogging to these coordinates and then set your coordinates there. You don't necessarily have to eyeball so as to make it so as to make the X and Y coordinates co-align to this point. Since you have already taken notes of these prior, then you can simply jog to these coordinates and set the home from there. That will lead to the same results, and you will be able to run your toolpath in terms of the X and Y. For the Z axis, it's not as straightforward. You will need to set the surface, as we demonstrated how you do, by using this, as well as the magnet of course, but by using this plate resting on top of the top surface. And if the previous toolpath, after the result of it, leaves such an area, then you can simply place it on that area. And that area, since it is a part of the original top surface, the result should be the same. But you will have to verify, since you have already taken note of the set surface. Here we had minus 105.70. You will have to make sure that after you set the surface, that when it retracts to the height in relation to that, it should be minus 105.70. If those two match within tolerance, of course, then you are free to go. But let's say that you have previously done a toolpath which does not leave any top surface. Well, then you'll have to get creative. Either find a horizontal spot on the machined model where you can rest some material, and then you can stack sheets of paper and then try to set surface, and then if this value is off, then you just adjust it with the number of papers, and then when you achieve this set surface amount, then you know that you have found the original top surface, and thus you have also found your Z0 home for the work already. But having spoken about this and realizing the complexity and perhaps arbitrary nature of doing this, and trying to mimic the circumstances so as to recover this value for the set surface Z, one may also point out the great advantage of offering toolpaths that you can reasonably do within one day. In this case, this toolpath only took 1/10 of its simulated time, and the expected factor of the relationship between the actual runtime and the estimated runtime is that the actual runtime is somewhere between 1/4 and perhaps half of the estimated value. But in this case, it only took 1/10 of the estimated value. But offering toolpaths that fit in one day's opening schedule of the workshop is a pretty large advantage when it comes to straightforwardness. Having roughly cleaned the space so as not to slip on the floor, and making sure that no sawdust covers the actual model, we can return to the CNC controller outside of the glass doors here, and we click the same button as before. The connection to the computer is established, and then right now highlighted is the previous operation that we did. We make sure that we go down, we jog down, so to say, in the menu one step to the next toolpath, and then we preview the toolpath with the enter key here. And now tool 2 is red, and that gives you visual confirmation that you have authored the toolpath with the correct tool number and that everything is in order. So you see that the toolpath is red, it's the second tool, and it is corresponding to our expectations in terms of the toolpath. Alright, and then we can click execute. The first thing that it will do is to leave tool 1 in the tool holder 1, and then it will fetch tool 2 from tool holder 2. So we'll press execute here, and when you are ready to execute, you click once again on the same button to confirm the execution. and it will leave tool 1 in tool holder 1, and fetch tool 2 from tool holder 2. Having done so, it will move to the home and start the toolpath. To reduce the risk of rubbing when pausing, it is a good idea to synchronize so that you pause if it's not a problematic precursor for pausing. Then of course you should pause immediately as possible. If it's critical, you should of course press the emergency button. But if you only want to check out the result, then it is good to find a time when the tool is not engaging in the material, when it is traveling in the air, because then there is no rubbing when it pauses in the X and Y position there. Alright, if you want to adjust the feed rate or the spindle speed, this is done with the CNC controller here. The feed rate is adjusted up and down here, the spindle speed up and down here. As you see, the feed rate always has its maximum value 100%, and 100% is the feed rate value that you have input in Fusion 360 and post-process as a toolpath. The spindle speed can be adjusted freely up to its maximum of 32,000 RPM, which is not advisable for any material, at least to our experience, but it can be adjusted up and down as you wish. Now we see here that the second toolpath, the roughing toolpath, is very soon to be finished. Now it is done. And you see there that the interface returns to its main interface. The spindle is positioned above the soft home, 15 millimeters above. And for this particular toolpath there was not much sawdust accumulated. Also because of the shipload per tooth that we set, there was very fine sawdust. It was still within adequate size, but definitely on the smaller side, which means that there is not as an excessive cleaning situation, but we should still clean up a little. So we can jog away. We can jog away here. First, of course, moving upwards in the Z direction, in the Z axis, and then we can move away here. Since the spindle was retracted 15 millimeters upwards, then we know that we will not collide with any of the existing stock, since it was 15 millimeters above the original stock surface, top surface, but one should rather be safe than sorry. Now we can clean up a little, again with the black hose or any way you prefer. Having cleaned up a little the machine bed and the floor here so as not to slip and so as not to leave sawdust on the model, we can start toolpath number 3, the finishing toolpath, the parallel toolpath. So, like with the others, we go here to the computer connection, and here we make sure to highlight tool number 3, the toolpath number 3, which uses the tool number 3 here. We press enter to preview, and this will have a purple hue, and due to the low step down of the toolpath file, this shows only as a huge purple blob filling out the whole vertical dimension of the screen. We'll have to trust in our correct observation of the toolpath simulation, as well as here seeing that it's correctly oriented along the long axis, along the x-axis. Very good. You can click execute to execute, and once again to confirm the execution. The first thing I will do is to leave tool number 2 in tool holder 2. Press execute to execute. So it will leave tool number 2 in tool holder 2. and it will fetch tool number 3 from tool holder 3. And here, if you want to adjust the feed rate and the spindle speed, one can do so while actually traversing the hole. So now we're at 75% feed rates and it's already adjusted. But I'll increase now again to 100%. And one can do this for the spindle speed as well. Alright, now that the third and final toolpath is complete, the finishing toolpath has reached its end. We see that the CNC controller's interface has returned to the main interface. We can, since we're now entering the CNC room, or going to enter the CNC room to do a end of day cleaning, a thorough cleaning, we should jog away the spindle, but first jog up in the Z direction, and then we can move away in the X direction. And if you have another finger to spare, you can do the Y direction simultaneously, but now I'll do it consecutively. Alright, and having done so, we can enter the room to clean up. Having finished your end of day cleaning in the CNC room, a very thorough cleaning, you can release the vacuum valve here, or actually shut it by clockwise turning it so it's closed position. And then having done so, we go back here and turn off the vacuum on the red button there. Having done so, the stock, or what remains of it, the model, should be able to, perhaps there's a little back suction here, and to release that you can slightly shift the material, so like you can shift it horizontally. Oh. Yeah, and that took no effort at all, and then it just released. Yeah, and here you see that it's good to keep the black hose so that you can clean up this small rest very, very quickly. So I'll just lay that there, and then I'll very good. Now we can put back the hose at its original position. Very good. And while here at the hose station, we can shift our attention to the cleaning station. And here, make sure to completely shut this valve. You remember that we opened this very slightly so as to make sure that the dust extraction works properly at 100% of the time, and not only when other machines in the workshop are active. And by closing this valve completely, we make sure that this is not unintentionally left open after the operation is completed. Now it is shut, the operation is complete. Very good. We can easily remove the vacuum sealing strips here by grabbing one end and then just very carefully going vertically here. And there might be some residue here, some sawdust residue left here on the machine bed. And should there be residues of sawdust here, you can simply blow them away. The main thing is that there should be no sawdust on the machine bed, so that the machine bed should be 100% level, not have any residual sawdust on it. Put the vacuum sealing strip in the vacuum sealing strip box here. Very good. The next thing you should do, having finished all 3 toolpaths, is to shut down the machine. Right now the CNC controller is the outside here, so we can grab it here and reposition it at its intended place. And one can also make sure to have this cable be resting on top of that. That makes it easy when we drag back the computer table back in, that it does not get damaged in any way. And then we can put the CNC controller at its resting place here. And then we can shut down the machine. When we shut down the machine, the CNC will automatically leave any tool it has currently in the spindle. So we do not need to manually, or we do not need to enter the command, the automatic tool change command, to unload the tool, because it will do so automatically during shutdown. But we can enter the menu anyway. Click menu here so as to enter the menu, and here you see, if you go click this set down button to go all the way down the list, and then up one we see shutdown. We click enter to confirm, and then one final confirmation: do you want to shut down the machine? And in this case we are totally finished for the day. We want to shut it down. So we click enter again. It will leave the tool. It will unload the tool. It will return to the original position of it, or the previous position of the spindle. And when the CNC controller says that the motor drives have been disabled, you are free to power down the machine. It also says here, OK to power down. We go to the back of the machine. Turn this counterclockwise to its off position, and the CNC machine is turned off. Then we make sure to break the current here as well, counterclockwise to the 0 position on the wall, and we have successfully turned off the machine. Having cleaned this area, we can turn off the lights and close the door. Make sure that the cable here is resting in a suitable position and not with these kinks. Very good. And then we can shut down the computer here. So we'll close that, and then we'll right click here, and we do shut down or sign out, and we sign out. And there is no option of shutting down this computer, at least not in the interface. But having signed out, we can shut down the machine by gently pressing the on-off button here. Just click it, and it will slowly go to being shut down. Drag in very carefully, especially above the threshold with the cables. Drag in the computer table to its original position inside here. Very good. Drag in the chair in the same way. And then be gentle above the threshold. I'll lift it up completely. And then position it here by the webcam. Bring out your model. Turn off the lights. Release the door and the door stop. You can put a door stop either inside or outside of the door. Close the door and make sure that this cable is not damaged. Very good. Very good. Before leaving the workshop, double check, make sure that this valve is closed. To trim away the edges of the bottom margin, you might use this vertical saw, and having done so and roughly made an outline of the intended outline, then you can sand away the rest with these sanders, or preferably utilizing the angles of this as well as the small angles, the small radii of these. With the model finished in terms of CNC milling, you are free to do whatever you like or whatever your intended purpose with the model is. In this case, we're going to make a vacuum formwork, a vacuum pressed formwork. All right.
Jag tror att vi kommer behöva några små bitar och sätta under här. Jag hade i alla fall provat det.
En radie.
Det är lite roligt med de vi jämför med, för att när man fäller ner modellen igen i maskinen släpper de ju aldrig. De sitter ju fast, men den här funkar. Ovanligt bra.
Jag tror att det var att vi körde såna här taperkanter också, om man säger. Att den inte är vass, inte 90 graders kanter. Den här var ju bättre.
Ja, den höll formen bättre. Eller höll...
Ja. Så ska de gå och stapla i varandra så här.